Our planet is in a state of flux. Temperatures are rising, ice caps are melting, and weather patterns are becoming more extreme. The scientific consensus is clear. Climate change is primarily caused by human activities, especially the burning of fossil fuels, which has led to a warming trend that can't be explained by natural factors alone, making it crucial to diversify our energy sources. We need to track these changes and comprehend their causes. This is where satellites enter the picture. Two groundbreaking satellites that could revolutionize climate monitoring. These satellites, known as the Atmospheric Environment Monitoring Satellite and the Terrestrial Ecosystem Carbon Monitoring Satellite, or GUMONG, use cutting-edge technology to track pollutants, greenhouse gases, and forest carbon sinks with incredible precision. The first satellite, the Atmospheric Environment Monitoring Satellite, is designed to track pollutants and greenhouse gases in the atmosphere. This information is crucial for understanding the causes and effects of climate change. The satellite uses a variety of sensors to measure the concentration of different gases, such as carbon dioxide, methane, and ozone. It also tracks the movement of these gases, which can help us to identify the sources of pollution and predict the impact of climate change. The second satellite, the Terrestrial Ecosystem Carbon Monitoring Satellite, is designed to track forest carbon sinks. Forest carbon sinks are areas of land that absorb carbon dioxide from the atmosphere. This is crucial because forests play a key role in mitigating climate change. The satellite uses a variety of sensors to measure the amount of carbon stored in forests. It also tracks the growth and decline of forests, which can help us to understand how forests are changing over time. Satellites orbiting our planet are our eyes in the sky. These technological marvels have revolutionized the way we understand and interact with our world. They provide a unique vantage point to observe Earth's systems on a global scale, offering insights that are impossible to obtain from the ground. These sophisticated machines collect valuable data about our planet's atmosphere, oceans, and land surfaces. They are equipped with advanced sensors that can detect minute changes in temperature, moisture, and other critical parameters. Satellite sensor data helps scientists monitor and understand the complex processes driving climate change. By analyzing satellite data, researchers can track the progression of global warming, identify hotspots of environmental degradation, and develop strategies to mitigate these impacts. There are two main types of orbits used by Earth observation satellites: geostationary and low Earth orbit. Each type of orbit serves different purposes and offers unique advantages. Geostationary satellites orbit at a high altitude of approximately 36,000 kilometers above the equator. This high vantage point allows them to cover large areas of the Earth's surface. At this height, they match Earth's rotation, effectively remaining stationary relative to a specific point on the surface. This unique characteristic makes them invaluable for continuous monitoring. This allows them to provide continuous monitoring of a particular region, making them ideal for weather forecasting and tracking the movement of weather systems. They can observe the development of storms, track their paths, and provide early warnings to affected areas. Low Earth orbit satellites, on the other hand, orbit at much lower altitudes, typically between 160 and 2,000 kilometers above Earth. These satellites move quickly across the sky, completing an orbit in about 90 minutes. While they don't remain fixed over a single location like geostationary satellites, their lower altitude allows them to gather higher resolution data and cover a wider swath of the Earth's surface with each orbit. This makes them ideal for detailed mapping and monitoring. This makes them well suited for a variety of applications, including monitoring changes in land cover. They can detect deforestation, urban expansion, and other land use changes with remarkable precision, tracking the movements of ships and aircraft. This capability is crucial for maritime and aviation safety, as well as for monitoring illegal activities such as smuggling and unauthorized fishing, and studying the impacts of climate change. Satellites can measure the melting of polar ice caps, the rise in sea levels, and the shifting patterns of vegetation and wildlife. This information is vital for understanding the long-term effects of climate change and for developing strategies to protect our planet. As technology continues to advance, the capabilities of satellites will only grow. Future satellite missions promise even more detailed observations and a deeper understanding of our planet. These eyes in the sky are not just tools for scientists. They are essential for the well-being of all life on Earth. One of the most significant impacts of climate change is global warming. The global warming phenomenon is characterized by a long-term increase in Earth's average surface temperature, primarily due to human activities such as burning fossil fuels and deforestation. Satellites play a crucial role in monitoring this phenomenon by measuring Earth's temperature from space. These advanced technologies orbit our planet, providing a unique vantage point to observe and record temperature changes on a global scale. They do this using instruments called radiometers, which detect the infrared radiation emitted by our planet. Radiometers are highly sensitive devices that can measure even the slightest variations in temperature, making them indispensable tools in climate science. By analyzing this radiation, scientists can determine the temperature of Earth's surface, atmosphere, and oceans. This comprehensive data collection allows for a detailed understanding of how different parts of our planet are warming. These measurements have provided undeniable evidence of a warming trend over the past few decades. The data collected shows a clear and consistent rise in temperatures, which correlates with increased greenhouse gas emissions. This data is crucial for understanding the rate of warming and its regional variations, allowing scientists to develop more accurate climate models and predict future climate scenarios. These models are essential for forecasting potential impacts on weather patterns, sea levels, and ecosystems. The information gathered by satellites is also essential for informing policymakers and encouraging action to mitigate the impacts of climate change. By presenting clear and compelling evidence, scientists can advocate for policies aimed at reducing carbon emissions and promoting sustainable practices. Ultimately, the data from satellites not only enhances our understanding of global warming, but also empowers communities and nations to take informed steps towards a more sustainable future. Through international cooperation and local initiatives, we can work together to address the challenges posed by our warming world. The melting of glaciers and ice sheets is one of the most visible consequences of a warming planet. Satellites provide irrefutable visual evidence of this phenomenon. They capture images of retreating glaciers and shrinking ice caps, documenting the alarming rate of ice loss in polar regions and mountainous areas around the world. But satellites do more than just provide visual confirmation. They also use instruments like radar and laser altimeters to measure the thickness and volume of ice sheets and glaciers. These measurements reveal the alarming pace of ice melt, which contributes to rising sea levels and has significant implications for coastal communities and ecosystems. Forests play a vital role in regulating Earth's climate by absorbing carbon dioxide from the atmosphere. However, deforestation, driven by human activities like logging and agriculture, is releasing this stored carbon back into the atmosphere, further contributing to climate change. Satellites provide a powerful tool for monitoring deforestation and assessing the health of our planet's forests. Using high-resolution cameras and other sensors, satellites can detect changes in forest cover over time, identify areas of deforestation, and even distinguish between different types of vegetation. This information helps researchers track the rate of deforestation, understand its drivers, and assess its impact on the global carbon cycle. As global temperatures rise, sea levels are also on the rise. This phenomenon is not just a distant concern, but a present reality affecting millions of people around the world. Coastal areas, which are home to a significant portion of the global population, are particularly vulnerable to these changes. The primary drivers of sea level rise are the thermal expansion of seawater as it warms and the influx of fresh water from melting glaciers and ice sheets. As the planet heats up, the oceans absorb much of this heat, causing the water to expand. Simultaneously, the melting of polar ice caps and glaciers adds more water to the oceans, further elevating sea levels. The consequences of rising sea levels are far-reaching and multifaceted. Coastal communities face increased flooding, which can lead to the displacement of residents and the destruction of homes and infrastructure. Ecosystems that thrive in coastal regions, such as mangroves and coral reefs, are also at risk, potentially leading to a loss of biodiversity. Satellites play a crucial role in monitoring these changes. Satellites provide a comprehensive view of the Earth's oceans, allowing scientists to track sea level rise with unprecedented accuracy. Understanding the factors driving sea level rise is essential for developing effective mitigation and adaptation strategies. Using advanced technology like radar altimeters, satellites can precisely measure the height of the sea surface. These instruments send radar pulses to the ocean surface and measure the time it takes for the signals to return, providing accurate data on sea level changes. By tracking these measurements over extended periods, scientists can detect long-term trends in sea level rise and identify regional variations. This information is vital for understanding how different parts of the world are affected and for predicting future changes. This data is crucial for predicting future sea level rise, assessing the vulnerability of coastal areas, and developing adaptation strategies to mitigate the impacts. By understanding the patterns and causes of sea level rise, we can better prepare for the challenges ahead and work towards protecting our coastal communities and ecosystems. The data collected by satellites is not only essential for understanding past and present climate changes. The data collected by satellites is not only essential for understanding past and present climate changes, but also for predicting future trends. By feeding this data into sophisticated climate models, scientists can project how Earth's climate is likely to change in the coming decades and centuries. These projections are essential for informing policy decisions, guiding adaptation efforts, and mitigating the worst impacts of climate change. Section 8. The evidence gathered by satellites is clear. Our planet is warming at an alarming rate, and human activities are the primary driver. The consequences of inaction are dire, ranging from more frequent and intense heat waves, droughts, and floods to rising sea levels, ecosystem collapse, and mass displacement of people. The fate of our planet rests in our collective action. The future of our planet depends on us. Moving beyond fossil fuels requires us to embrace a diverse array of energy solutions, such as invest in renewable energy sources and adopt sustainable practices to reduce our environmental footprint. The data provided by satellites serves as a stark reminder of the urgency of this task and provides us with the knowledge we need to make informed decisions and protect our planet for future generations. We must act now, for the sake of our planet and for the well-being of humanity. Thank you for watching. And if you would like to continue learning more, watch this video next. And be sure to like and subscribe to stay up on the latest tech trends.